So in this video, I want to just give you some information about how to calculate the minimum sample size if you are given a certain confidence level and margin of error, and you want to construct a confidence level for the population mean. So the formula here for n, that minimum sample size, is we'll take z of alpha over 2 times s all over e, and this is going to be squared. And don't forget, with minimum sample size calculations, you always round up. So let's look at the pieces in this formula. Z of alpha over 2. So this is determined by a confidence level, and you may recall in when I was in a previous videos about confidence intervals for the proportion, I gave some of the common values of z of alpha over 2 that are correspond to these pretty standard levels of confidence. So for instance, for 90%, this we use 1.645. For 95%, we use 1.96, and for 99, we can use 2.57. And depending on where you're looking, you might see this as 2.575 or 2.576. So we're going to use one of these values here for z. So when I'm saying you have a certain confidence level in mind, you would now if it was a level of confidence that's not listed here, remember, for instance, let's say you wanted to find this value for maybe a 96%. Remember that that confidence level is the area that's in the middle of the standard normal curve. So if you take 1 minus that confidence level, we get alpha. And so in this case, alpha would be 4%. But half of that is in this tail and half of it's over here. So I have to divide that by 2. That's why we say alpha over 2. So this would be 2% and 2%. Now notice when I add up these three values, I get 100%. So I'm looking for z for alpha over 2. So that's z for 0.02. So I can use my inverse t function with 0.02. Now, I'm sorry, that's inverse t. I want the inverse norm. Clear. And so I would put in 0.02 and 0 and 1 because that's the mean and the standard deviation for the standard normal curve. And I can find that this is negative 2.05. And you can just use the absolute value of that. So this z-score here is negative in this one spot. Now, we're talking about this minimum sample size for a confidence interval for estimating the population mean, and I've been using a t-critical value to do this. Now, it's a natural question, why am I using a z-score all of a sudden and not here? Well, remember that these values are determined by degrees of freedom, and we're using n minus 1 for degrees of freedom. Now, n is the sample size. Here I'm trying to find the minimum sample size, and so it makes sense that I wouldn't know it, so I won't be able to look up a critical value from the t-distribution, and that's why I'm using the critical value from z, z of alpha over 2. S would be the standard deviation, and this would be from some prior estimate, and then here is your goal for the margin of error. So let's say that you're trying to estimate a mean and you want to use 95% confidence. You have a prior estimate for the standard deviation. Let's say that it's 7.5, and your goal is to be able to estimate the mean to within 5 units. So let's say that we're going to use 5 here. So I can do the calculation by saying n equals, so since my confidence level is 95%, I'm going to use 1.96, and the estimate that I have for the standard deviation is 7.5, and my margin of error is 5, and I want to square this. So I take 1.96 times 7.5, divide that by 5, and square the result. And I would get 8.64, and I need to round that up to 9. So the minimum sample size would be 9. Now that's a relatively small sample size, but notice I was giving myself a good bit of wiggle room of 5 units when a standard deviation is 7.5 units. So all right, so that's an example of a minimum sample size calculation. All right, that's it for this video.